Limit describe how a function behaves near a point. So what does this statement mean? Let us take the function y equals to 2x. Graphically, y equals to 2x is shown like this. We have x and y. Now, let's say we want to know the limit of y when x approach to 2. To do this, we take the approach first from left to right. So what we are doing is we are trying to look if we move from left to right, what does this limit of y approach to 2 result? It turns out that y also approach to 4. And the second one, so we do the first one is we do the left side limit. It's called the left side limit. And the second one, we analyze from the right side limit. We do the same thing, but we move from right to left, From right to left, it turns out by analyzing the graph, it also approached to 4. A limit exists if left side limit and right side limit are equivalent. So let's look at another example. Here we have 4 graphs that we will look one by one, and I want to point out here that instead of x and y, we have v at the x-axis and q at the y-axis. And here so q is a function of v. And we are also trying to analyze the limit of q when it approaches to n. The first graph here, it is a smooth graph, so don't get disturbed with the arrow. You can imagine that this is a smooth graph. As what is the limit of q when v approaches to n? If we look from the left side limit, the function approaches to L, and from the right side limit too, as v approach to n, the function also guide us approaching to L. So from this first graph in part A, we can say that the limit exists because the limit as v approach to n, the limit of q is equal to L. Both of them equals to L, so the limit exists. What about part B here? It has a sharp point at the end, so it's not a smooth function. As v approach to n from the left side, it approach to L. And as v approach to n from the right side, it also approach to L. So we can say, yes, the limit exists. So the limit q as v approach to n is equal to L. And let's see the third curve here. It is disconnected at n. So if we look as v approach to n, but remember v is not equal to n, from the left side, v approaching to n from the left side, the function equals to L1. From the right side, as v approach to n, the limit of q is equal to L2 because we are following the curve for v smaller than n, then we can say that the range is in L1. For v greater than n, the range is in L2. So the left side and the right side does not have an equivalent limit. So here, the limit does not exist. Now, what about point D? As v approach to n from the right side, it turns out it is approaching to positive infinity. Limit q v approach to n from the right side, it is the result positive infinity. And limit v from the left side, the limit of q from the left side, it approaches negative infinity. Again, this one limit does not exist. As a last remark, I would like to emphasize that when analyzing the limit, actually we are saying that the x here is a very small number. So a very small number approaching to 2 from the left side or the right side. Or in other words, if I show you through numbers here, this is the example of analyzing the limit of y from the right side. So from the right to the left, the x 2.1, 2.001, 2.0001, it is approaching to 2, and it's not equal to 2, but it has a very small difference. And the result we see is approaching to 4. And this is if we are analyzing from the right side, from 1.9, 1.999, 1.99999. X here is not equal to 2, but approaching to 2, and a very small difference with 2. And the result of the limit of y is approaching to 4. So from the right side and the left side, both approaching to 4.